Okay, so if you remember what we were learning last week and what we just took a quiz on last week, we were learning all about different graphs and their domain and range, which means what they have for the x values and what they have for the y values. We were learning about functions, what is a function and what is not a function. We looked at function notation quickly, and we looked at whether or not something would be a linear function or a nonlinear function. So what we have in this next section, this begins section 3.4, and 3.3 was all about what I just explained. 3.4 starts out with equations in a certain form. The form is called standard form. What we're going to be doing today is looking at linear equations. Linear equations, if you remember, is basically a line, a straight line. So any equation that has a straight line is considered a linear equation. That means that it either increases or decreases with the same number each time. It has a constant rate of change. And when you graph that, it looks like a straight line. We're going to be looking at this certain form here of linear equations. The form is ax plus by equals c. And all of these numbers here for a, b, and c, these will all be numbers. So they're not going to be variables. They're all going to be numbers. For example, an equation in standard form can look like this. 2x plus 3y equals 6. That's an equation in standard form. That's an example of one. So a number is in front of x, a number is in front of y, and then equals a number here. A solution of a linear equation with two variables is an ordered pair. We know ordered pairs are x comma y, and that ordered pair makes the equation true. So in this example, we want to determine whether this ordered pair here is a solution to this equation. So what we'll do is take the equation x plus y equals 7, and we're going to use this ordered pair to see if this is true. Because this ordered pair has 2 for x, and 5 for y, we will replace 2 in for x and 5 in for y and see if it is true or not. If it is true, then the answer is yes, it is a solution. If it is not true, the answer is no, it is not a solution. 2 plus 5 is 7, and since 7 equals 7 is true, the answer would be yes, it is a solution. And we don't have to write all of this all of the time, but I just am going to write that out for our notes since this is our first time doing this, that yes, 2, 5 is a solution, but you could just write solution or yes. Same type of thing for the next one. Now we want to see if the ordered pair 2, 5 is a solution to this equation. So this is a brand new equation, 2x minus 3y equals negative 11. And I'm going to be doing the same thing. I'm replacing in 2 for x and 5 for y because the ordered pair is the same. But then I have to do a little bit of solving because it's not going to be as easy as just 2 plus 5. So this is going to be 2 times 4 minus, what am I doing? Sorry. 2 times 2 minus 3 times 5. We're going to see if that equals negative 11. So 2 times 2 is 4, that's what I was doing, minus 3 times 5 is 15. And then we would just solve this. 4 minus 15 is negative 11. Because negative 11 equals negative 11, this would be true. Yes, it is a solution. So 2, 5 was a solution to both of these equations. The ordered pair doesn't have to always be 2, 5. They can be anything. It's just a coincidence that this was the same exact one. So similarly, what I want you guys to do is try these next two problems. It's going to use the same ordered pair for both. Now the ordered pair is 3, 2, but two different equations. So go ahead and replace 3 in for x, 2 in for y, and see if 3, 2 is a solution to this first equation, and see if this is a solution to the second one. I'll give you maybe like 2 minutes, and then we'll go over the answers. All right, let's go over these answers. So the first one, we're replacing in a 3 in for x and a 2 for y. So this will be 2 times 3 plus 3 times 2, and we want to see if this is equal to 12. Well, 2 times 3 is 6, 3 times 2 is also 6. Since 6 plus 6 equals 12, this answer would be yes, it is a solution. And then the next one, 2 times 3 plus 4 times 2, let's see if this is equal to 10. 2 times 3 is 6, 4 times 2 is 8, and 6 plus 8 does not equal 10. 6 plus 8 is 14. Because this does not equal 10, this answer would be no. It is not a solution to that equation. So the equations that we're seeing, these equations are called standard form equations. They have a number in front of x, and then a number in front of y equals a number, and you can easily take ordered pairs to see if they are solutions by replacing in those numbers for x and y. We've been seeing a lot of practice problems with these types of standard forms, but we never really called it standard form yet. So what we have here, 1, 2, 3, 4 keystone practice problems. I want you to please complete 1, 2, 3, and 4. They shouldn't take that long. You're just going to read the situation and then decide if the ordered pairs represent the solution to the equation and what do they represent. So I'll give you maybe like 4 minutes for the 4 problems, 1 minute per problem, and then again we'll go over the answers and move on. All right, so when we are doing these types of problems, we have to read the situation and then look at the ordered pair, make sure that the answer to the ordered pair is in the correct order and the numbers associate with the correct thing. So number 1 says Jake bought X pairs of thermal socks and Y shirts at the department store. He spent a total of $80. The following equation describes the relationship between the number of pairs of thermal socks and the number of shirts purchased. We have 11X plus 18Y equals 80. So I can see the $80 in the equation. It's equal to 80 right here, and I can see that this is 11 times X plus 18 times Y. They're telling us X is the number of thermal socks he's buying, so it's 11 times X is the number of thermal socks. And then Y represents shirts. It looks like it's 18 times Y here. So now we're looking for what 4-2 represents. It's important to realize X is about socks and Y is about shirts. So when I'm looking at this ordered pair, it's important to realize that 4 is going to represent socks and 2 is going to represent shirts. That will help you cross things off and try and find the right answer. When you are taking a test like the Keystone or like the PSATs and SATs, it is really helpful to take answers and kind of cross them off as you go and use test-taking strategies to find the correct answer. So it says here A, shirts cost 2 times as much as socks. So if I'm looking at the equation is 11x plus 18y. And if x represents the number of socks you're buying, then the 11 is actually the price of the sock for each pair. And then if y is the number of shirts you're buying, then $18 is the cost for a shirt. So A is not true. It is there to trick you because 2 times 2 is 4, so it might look like that's true, but it's not actually true. 2-4 represents 4-2 is going to represent how many pairs of socks and shirts you're going to get. So letter B says Jake purchased 4 pairs of socks and 2 shirts. Well, that looks pretty spot on since 4 represents socks and 2 represents shirts. So it looks like B is going to be the answer, but let's just show you why C and D are not answers. Socks cost $4 each and shirts cost $2 each. This one can very easily trick you because you see the socks for 4 and shirts and 2 in here, which it looks like the same as this. But actually in the equation, 11 represents how much it costs per pair of socks. X is the number of them you're buying. And 18 is how much it costs per shirt. So that's not true. Neither is D. It has to be B. Now they tell you that X represents how many pairs of socks and Y represents how many shirts they're buying. So the answer, when they give you an ordered pair form, it will have to be about how many, not about the price. Number 2 says Francisco purchased X hot dogs and Y hamburgers at a baseball game. He spent a total of $10. The equation below represents the relationship between the number of hot dogs and the number of hamburgers he purchased. So X is hot dogs, Y is hamburgers. It looks here, if X is the number of hot dogs, it looks like it's going to be $3 per hot dog. And if Y is hamburgers, it's $4 per hamburger, and that's going to be equal to $10 total dollars. So the ordered pair 2-1 is going to represent what? A, B, C, or D. That hamburgers cost 2 times as much as hot dogs. That he bought 2 hot dogs and a hamburger. Hot dogs cost $2 each. Hamburgers cost $1 each. Or he spent $2 on hot dogs and $1 on hamburgers. What do you guys think? Anyone here? Anyone at home? A, B, C, or D? Yes. Thank you. All right, so this is going to be B. And then these are very simple. At the theater, he purchased X popcorn and Y drinks, spent a total of $26. I feel like all of the answers are in the same spot, which is so silly. But number 3's answer is B as well. And then number 4, apples cost 20 cents each while oranges cost 30 cents each. You spend a total of $3.50 on fruit. The equation 0.20x plus 0.30y equals 350 models the situation where x is the number of apples and y is the number of oranges. Which of the following is not a possible solution to the context of the problem? So number 4 is the first one that's a little bit different. They're asking us to actually see which one is not a solution to the equation. So that means that we would have to take our calculators and replace all of these ordered pairs into the equation to see which one is the only one that does not work. That means that if you're going to have 1 apple and 11 oranges, this ordered pair would be 1, 11. This ordered pair, since apples is x, right? Yeah, x is the number of apples and y is the number of oranges. This one would be 7, 7. This would be 11, 1. And this would be 4, 9. What they want us to do is take all 4 of these ordered pairs and replace them in for the equation 0.20x plus 0.30y equals 350. Okay, so I have to do that with my calculator as well. So we'll try the first one. So that means I'm going to replace a 1 in for x here. 11 in for y, and see if this is equal to 350. Well, 0.20 times 1 is obviously 0.20, plus 0.30 times 11 is 350. The first one works. We're looking for which of the following is not a possible solution. So it's actually not going to be A because A does work. Let's try B. I'm just basically changing this into 7s for here, and this is a 7. So 0.20 times 7 plus 0.30 times 7, that's also equal to 350, so it's not B. Changing the next one, this is going to become an 11, this is going to be a 1. So 0.20 times 11 plus 0.30 times 1 is 250. So B definitely does not work. This doesn't equal 350. Let's just verify there's not more than one answer by replacing in a 4 for x and a 9 for y. 0.20 times 4 plus 0.30 times 9 equals 350. So B is the only one that does not work. Okay. So all of these examples, the equations were in standard form. Standard form equations have numbers on the left-hand side with x and y, and then equals a plain number on the right-hand side. The last thing we're going to be doing is looking at linear equations and graphing them. So this is a start to a whole new idea with graphing lines, and this is where Algebra 1 really starts. So if you're kind of feeling like, well, this was easy, that's great, but this is now going to be new material, so please make sure you're paying attention and keeping up with this, because this is going to start to get really difficult really quickly. So, graphing linear equations in standard form. There are 2 methods for graphing an equation in standard form. One method is using intercepts. So, every single linear line, which is a straight line, crosses the x and y axis at some point. Well, not every single one, but most of them do cross the y and x axis at a certain point. The x-intercept is where it crosses the x-axis. So if we look here at this graph, here is the x-axis. The x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. We can see that that line crosses the y-axis right here. So that's where the y-intercept would be. And the x-intercept is where the line crosses the x-axis, which would be right here. So to graph linear equations in this form, ax plus by equals c, which is a standard form, what we can do is find the x and y intercepts and then draw a line through them. So to find x and y intercepts, it's a little bit confusing because when you're finding the x-intercept, you actually let y be 0, and when you're finding the y-intercept, you let x be 0. So let's take this standard form equation, 2x plus 4y equals 12. And we're going to be finding 2 things. We're going to be finding the x-intercept, and we're going to be finding the y-intercept. Okay, looking at a graph, your x-axis is right here, Your y-axis is up here. The x-intercept is going to tell us where this line crosses the x-axis. Wherever it crosses the x-axis, we would just make a point, and that's where it would cross. To find the x-intercept for 2x plus 4y equals 12. If you look up here at the notes, to find the x-intercept, let y equal 0 and solve for x. That's because when you are on the x-axis, all of these points, whether you are here, this point is at 2, 0, or you don't have to write this on your paper, I'm just showing you, or it's here, this is 8, 0, or here, negative 3, 0. Every single time you lie on the x-axis, the ordered pair has a 0 in for y. And that's because when you are on the x-intercept or x-axis, you don't move up or down anything, so that second point in the ordered pair is a 0. So when we're trying to find the x-intercept, what we do is we take the equation and we replace a 0 in for y, and we solve. So it's going to be 2x plus 4 times 0 equals 12. We're replacing in a 0 in for y because when you're on the x-axis, 0 is what y is going to be since you don't move up or down anything. Well, 4 times 0 is just 0, so it kind of just goes away, and we're left with the little equation 2x equals 12. To solve these, it should be very simple. You only will ever have to do one step, which is just divide in this case, and we're going to get x is equal to 6 since 12 divided by 2 is 6. What this means is that the line crosses the x-axis at 6. So you will go to the x-axis, which is your horizontal line. You will go over to 6, and you will make a point. And the reason why you will make a point there is because this is where it crosses the x-axis. It crosses the x-axis at 6. The ordered pair for this is 6, 0, because y is 0 when you're on the x-axis, and it crosses here at 6. To find the y-intercept, we basically do the same thing, but the opposite. We take the equation 2x plus 4y equals 12, and then we are going to find the y-intercept by letting x equal 0 and solving for y. So opposite of what we did the first time, now we're going to make x be 0. And that's because when you are on the y-axis, for all of these points here, whether it's this point here, 0, 2, or this point here, 0, negative 8, or this point here, 0, negative 2. All of these points have 0 in the x place. And that's because when you lie on the y-axis, you don't move left or right anywhere. So 0 is what your x number will always be when you are on the y-axis. So when we go to find the y-intercept, I know that x is going to actually be 0. So I replace 0 in for x, and then I solve the rest of the equation for y. 2 times 0 is 0, so it just goes away, and I'm left with 4y equals 12. When you go to find the y-intercept, you should only have the y variable left. When you go to find the x-intercept, down here you should only have the x variable left. If you had the opposite ones, you're finding the opposite intercept. To solve this, we would just divide both sides by 4. We get y equals 3. That means that this line crosses the y-axis at 3. So you would go to 3 on the y-axis and make a point. The point for that is 0, 3. That's because we know that when you're on the y-axis, you have 0 in for x, and then it's up 3, and then I accidentally erased this point that I need. This is 6, 0. Once I have my x and y axis drawn on the graph, then it's time for me to draw a line through those 2 points. So in a traditional setting, we would all have rulers, and I would ask you guys to use a straight edge like a ruler or like a notebook or something like that. If you have something like that at home, it is helpful. But when you're drawing linear lines, you want them to be as accurate as possible. For now, I'm just going to be sketching a line through this graph here. When I draw my lines, I connect the points and draw the line all the way from one side of the graph through the other side. I like to put arrows on both ends because these lines do go on forever. They're continuous. So if you remember with what we just learned, linear lines are continuous equations because they don't have any breaks in the graph. They will continue on without any breaks or holes in the graph. Okay, so that's finding x and y intercepts. Now, there is another way to graph equations, and that's by rewriting the equation and solving for y, but we're going to be skipping that for now and coming back to that method. And I want you guys to try this next one on your own. So I want you to take the equation 3x plus 4y equals 12. And I want you to find two things, the x-intercept and the y-intercept. You can use the previous example to help you if you forget how to do this. But when you find the x-intercept, you make y turn to 0. So when you find the x-intercept, you use the opposite variable and turn it into 0. So that you're left with a little equation that has x in it. It should only take like 1 second to solve it because it will just require you to divide. Once you get that, then you know where it crosses the x-axis. The y-intercept, you will do the opposite. You're going to make the x variable turn to 0, solve the little equation that has to do with y, and that's where it will cross the y-axis. So I'll give you a few minutes to do that, and then again we'll go over the answers together as a group. Alright, so let's quickly go over these and call it a day. So when you're finding the x-intercept, it should be very quick and easy to do this as long as you understand what's going on. When you're finding the x-intercept, you take the equation 3x plus 4y equals 12, and you take the opposite variable and turn it to 0. So when you take a y and you turn it to 0, 4 times 0 is going to be 0, so basically this whole thing goes away. When you're finding the x-intercept, you should only have an x left. The equation you're solving is just 3x equals 12. So I like to actually almost take my hand and just cover the opposite one and then write down what's left, which is 3x equals 12. Then when you go to solve this, you divide by 3 and you get x is equal to 4. That means that the x-intercept, where it crosses the x-axis, is at 4 on the graph. So you would make a point at 4, 0, since when you're on the x-intercept, when you're on the x-axis, 0 is what y is going to be. So you would just plot 4, 0, and call it a day. For the y-intercept, you're doing the opposite. You're taking the equation 3x plus 4y equals 12, and because you're trying to find the y-intercept, and when you're on the y-axis, x is 0, you replace a 0 in for here, and it essentially goes away. Then you're left with the little equation 4y equals 12. You'll divide both sides by 4 and get y equals 3. That means that this equation is going to cross the y-axis at 3. So you go to the y-axis, go up to 3, plot a point there. That point is at 0, 3. And then once you have your x and y-axis plotted, your x and y-intercept, I should say, then you connect the points to the best of your ability. I'm just sketching it. You draw a line all the way through one side of the graph to the next. And that is the equation in graph form for 3x plus 4y equals 12. And that is one way to graph, by finding where it crosses the x-intercept, where it crosses the y-intercept, and then you would plot the points and connect the line, and there's the graph that represents all of the solutions to 3x plus 4y equals 12.